Right. So like I said, joins are quite an important concept in SQL. The reason being that, as we all know, in database management, data is stored in relational bases are stored in what? In tables, right? Now, so you might have something in one table and you might have other things in another table. So, but you want to see what you want to see what you have in a combination of tables or multiple tables all at the same time. So you need to be able to find a way to have a presentation that puts these tables together, or whichever tables that you want to view at the same time. You want to find a way of putting them together so that you have a single view of multiple tables. And now this is where joins come in. So joins, just like the name suggests, is used in joining one table to another. All right. Now there are 6 main types of joins. 6 types. What are these 6 types of joins? EB has given us some already. We have the first one is inner join. We have what is called the inner join. We have just join. Let me just use this join. Then we have inner join. We have EB, what did you say? We have left join.
Join.
Pardon? We have right join. We have full join. And you said outer join, right?
Yes.
I'll hold on to that for now. I'll hold on to that for now. And we have 2 more types of joins, actually. The cross join. And these joins are not very common. These last 2 are not common. And we also have what is called the self join. Forget about this one here. There are 6 main types: inner join, left join, right join, full join, cross join, and self join. These are the 6 main types of joins that we have. Now, why did I say forget about this one? Is because this and that, the first and the second, are the same. They are one and the same things. So most people will just, when you just use the join without specifying what type of join that you want to do, it automatically assumes that you want to do an inner join. Do you get me? So anytime you just use the word join without any specification, it defaults to this join here. Right. So let's see how we can use these joins. Let's first of all look at inner join. What do we mean by an inner join? So like I said earlier on, a join is usually, you would first of all do 2 tables. And if you want to add more tables, you can keep adding, but at each point in time, you would have 2 tables. So assuming you want to do 4 tables, right? You do the first 2, and then you add a third, and then you add a fourth. So when you do the first 2, you have 1 table. You can add a third to have another table, which you can add onto the fourth. So at each point in time, you have 2 tables that you add. Right. So the inner join, how does that work? Before we go on to do, I want to use the AdventureWorks database so that we see, I would use it at some point. But let's look at something here. Let's use, let me see, let me change this source. We would be moving between different databases so that we can use both. Because if you don't use the AdventureWorks, which is what you have, you might not um you might think it's difficult to use if we just restrict ourselves to the database that I have been using to teach. So I'll mix up the tables. I'll mix up the databases, okay? So let's say we run this query, select all. And let's first say from employees. Did we talk about aliases the last time? Or have we ever spoken about aliases? I think we have, right? When we start specify, in the beginning, when we
Yes,
specify
we
the
have.
format of SQL, how the queries are run, I think we specified the use of aliases. And what aliases do basically are to shorten repetition or to make your query look nicer and not too wordy. So, for example, if I want to use employees in multiple parts of the query, instead of repeating employees, I can just say, give it the alias E, right? So, and at this point, I have told the system that I want to call employees E, just that. So that E here, that you see, is an alias, right? Now, let's look at this. Let's execute this and see what we have in there. So you would see that in the employee table, we have employee name, start date, and then employees' addresses. Right. Do we have also an address table? Assuming we want to find, for example, where employees in the company live. Assuming we want to find where employees in the company live. Company locations. One moment. Okay, let me see. There should be an addresses table somewhere. Okay, okay. Yeah, that's it. That's the addresses table. Right. So assuming we want to find where employees live, right? We have the general employees table. And then we also have an addresses table. So in the employees table, in this table, what do we have? So this employees, right? We have just the address ID. Look at it. Okay, let's just, you see, in this employees table, we only have the address ID, but we don't have the address where the employees live. So for example, if I tell you that, tell me where Rebecca Baldwin lives. If this is the only table you have access to, will you be able to tell me? You would come into this table and then you would see that Rebecca Baldwin has an address ID, which is 10104, right? Does that give me any information? Obviously, no. So assuming somebody asks you, where are you going? And you say bus stop. Which bus stop? Or I ask you, where do you live? And you tell me number 59. Obviously, there are millions of houses numbered 59. So it really, really doesn't help if that is all the information that can be provided. But obviously, having this table and having this address ID, we talked about primary keys, remember? And we also did we talk about secondary keys and foreign keys? I'm not sure we did those things, but at some point we might do them. So you would see that this person ID here, which stands for the employee, would also be in another table. If for example, I open the addresses table, let's see. If I open the addresses table, we might just, where is addresses now? If I open up the addresses table, so you see this address ID here, which is in addresses table, that is what is here. Okay. Now, so this employee table has been linked to the addresses table by this address ID. Okay. Right. So if we want to join these two things, to know where the employees live, to know where all the employees live, what we need to do is to join the employee table to the addresses table. Okay. So let's see. We can therefore write this as inner join addresses 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 the addresses on the employee table. Remember, we've given this employee an alias, right? We've given this employee an alias. So we want to basically we want to find where the employees live, okay? So we have taken the addresses in the employee table by the addresses ID. And we are telling the system that wherever it sees this addresses ID in the employee table, it should join it to the addresses ID. So at this point, we have also given addresses table an alias in the addresses. We have given addresses table an alias A, right? Join it to the addresses ID in the addresses table. Inner join addresses on addresses ID is equal to a dot address.
I guess after that inner join addresses, you're supposed to put the alias.
Pardon?
Are you not supposed to put the alias for these addresses after this inner join addresses? Inner join addresses.
Oh, thank you. Yeah.
A.
I should name the alias here. That's correct. Okay, so see, just that simple thing, and then it throws everything out. Right. So what we have is this. We are saying that we are joining the addresses in the employees table by their address ID onto the addresses ID in the addresses table. Okay. Now, when we execute this, what do we have? This is what we have when we run this thing. And you see that this gives us 108 rows of data. It gives us 108. Take note of this figure here, 108. We would come back to it. But before I go on to the next query, I want to, because I've used this table. So let me use this also in the adventure works so that you see that it doesn't matter which database you have, you can run the same query, okay? So if I just copy all of this and then just change a few things. Now I'm going to use adventure works. Adventure work. Is it work or works? Adventure works database 2020. Okay, so let me change my source now to that. So here too, all we want to do is let's select from the employee table, that's called dim employee. Dim employee. And we can give it the same alias E, it doesn't matter at all. We want to join this, inner join this onto the dim employee sales territory. So here we want to see which employees are in which sales territories, okay? Dim employee sales territory. Let us call this T. We want to join this onto the employees table. So in the employees table, we are going to select, what do we have there? Let me go into that table so that we know exactly what we are talking about. Employees. Where are you? Dim employee. So what we want to pick from this is the employee key. Employee key, right? So join it onto employee key. Employee key. And this should be equal to right. So what we have here, what we are saying basically here is that we want to select from the dim employee table, right? And we want to join the dim employee sales territory. We want to find out which employees are in which sales territory. And to be able to do that, we take the employee key in the employee table and we match it to the employee key in the sales territory table. Is that making sense? We take the employee key in the employee table, right? Employee key in the employee table, and we match it to the employee key in the employee sales territory table. So that is what this here is doing. All right. Now, if we run this, you would see that that also gives us something. So here we would be able to say which employee works within which sales territory. So these are the sales territories here. And we'll be able to tell which employee works within which sales territory. All right, but let's go on with that. Let's use something that we can easily see. Like I said, we'll be mixing it up. Now, I said you should take note of the number of rows we generated under this one. That gave us 108, right? We can use this again to do what is called a left join. Let me change the source. Instead of changing the source here, I could have just written here, and then I name the table, okay? It's the same thing. But because I'm mixing up tables, I like to change it from here. Okay, so this one we want to do a left join. Now, the good thing about this is once you have gotten your format for doing one join, you can just, all you need to do is just keep the same format and just change the name of the join that you want to use. So in this particular instance, if we want to do a left join based on these same parameters, all we do is to change this to left join. To left join. And what does this give us? How many records do we have produced by this? 136. What is it that brings about the difference? And this is very, very critical. So in this join, we had 108. 108. But in this join, we are having 136. Who can tell me why we have the difference? Okay, let me help you. Now, when you do an inner join, what you are telling the table to do, what you are telling the system to do, is to take everything you have on the left table, that is the employee table, and join it onto everything you have on the right table, that is the addresses table, so long as what you have in the left table has got matching records in the right table. So listen carefully to that. You are telling the table to take everything you have in the left table and join it to things in the right table, so long as you have matching records of what you have in the left table in the right table. Okay? So if we run this query again, is that the table query? Let me just execute it again, just to make sure. So this gives us 108. And it's basically made up of everything in the left table, in the employee table, but would only pick up things in the addresses table if what is in the employees table has got matching records in the addresses table. So basically what it is saying is that if we have employees who are not named in the addresses table or who do not have addresses in the addresses table, their records do not show. Sorry, give me one moment. I have somebody at my door. Okay, sorry about that. Right. On the other hand, if we run this query here, we get 136 rows. What is that telling us? When we did this query, we got 108. We did this query, we got 136. That means that when we do this table, we lose some data, right? Simply because some of the records in addresses table are not in the employee table. So it will only give us those records in the addresses table, which are also in the employee table, right? But in this instance, what happens is that the system gives us everything in the employees table, regardless of whether we have records of these parameters in the addresses table. So it produces everything in the left table, whether or not there are matching records of these in the right table. Is that making sense? Which is why in this instance, we have more rules, more records are produced for this one than we have for that. Okay. Any questions so far? Now you would see that if we were to do this on this other one too, we would get the same thing would happen. If we were to change this to that, when we run this, let's see what we get when we run that. We have 39. We would have 39 here if and only if everything in the left has got matching records in the right. Otherwise, it wouldn't be the same. And here we have 317. You see how much data we've lost using an inner join on this. We use a left join on that, and we had 317. We use an inner join on the same query, and we had only 39. So basically, what does that tell us? If you want to see what exactly there is in if you want to have everything that you need to know about the employee, then what do you do? A left join is preferred or is better. However, an inner join is also better for performance. You want to see exactly what the situation is. You want to see the performance. You want to see exactly how your elements in the left table are comparing with elements in the right table. You want to see the exact recordings of these elements. Then an inner join is best to use. On the other hand, you would use a left join if you just want to have a general overview of everything that is happening in your database. And most of the time, you would use a left join. In fact, 95% of all your queries in joins, 95 to 98% will be either inner join or left join. Inner join or left join. Right. Having said that, let's look at other kinds of joins. Let's look at the right join. So like I said, all we do, if we want to do this, is just to change one word. So we want to run this, we just change the inner, or which, anyway, okay. So just write. And we can execute this and see what we get. Right. Now, so just like the left join, what is happening here is that you are telling the system to take everything you have in the right table. So here in the left join, the left table becomes the main table, right? In here, the right table becomes the main table. Right. And this gives us 109 results. However, the right join has got issues. It has problems. Look at this case, for example. When you use a right join, what essentially happens is that it picks up elements in the left table, sorry, in the right table, and matches them onto elements in the left table, regardless of whether or not there is an existence of any record. So assuming your left table is your main table, and not, most times that is what it is. So you have your main data in your left table, which is your employees in this instance, right? Your employees are your main focus in this query. Now you want to see where they live, right? But you are starting from the addresses. Mind you, there could be certain addresses where you don't have employees. So what this basically is doing is it is discounting the fact that that could be a possibility. And it is taking the position that whether or not employees live at an address, I am going to produce that record anyway. So the right join, 99% of the time, is not a good join to do. And it is not advisable that you do a right join. You can do it depending on the circumstance, but it is not advisable to do a right join. Am I making sense? Am I making sense? I hope I am. I hope I am. Okay, so when you are, and this is also, this could be an interview question actually. So how do you solve the problem of a right join? How do you solve the problem of a right join? Can anybody tell us how we can do that? because obviously the right join has got a problem. It has an issue. And now, even to clarify this, let's assume you have an electoral register. You know, we just did elections in the UK. So assuming that you want people to come and vote, what you are saying is that even if there are no people in a particular address, you are going to put them on the electoral roll anyway. You don't care, right? You're going to put them on the electoral roll. It's just like the case in some African countries where um, some parties would register even cows as human beings in addresses that don't exist. That is the case we have here of the right join. Right. So the right join has got an issue. How do we solve the problem of a right join? Assuming you go to work and you are told to run a right join, what would you do? Anybody? Anybody, everybody. Oops. Oops, 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 oops. Anybody, everybody. If we say we should never do a right join, then what do we do?
But use the left join.
Exactly. But how do we do that? Who spoke just now?
Maybe.
Maybe, how do we do that?
I used the left join to join the tables.
Yeah, we have already used the left join. But in case, assuming you have a right join already here like this, how do you change this right join to a left join? How do you do that? Very simple. All you need to do is these are the leading tables. Employees, the leading tables are what? The left table is employee table. The right table is addresses table. Right? Employees table, addresses table. So all you do in this instance, swap. Swap the leading tables. And change right to left. Swap the leading tables. This is what we have at the moment. So we are saying swap the leading tables. Simple. And change right to left. Swap the leading tables and change right to left. That is how to solve the problem of a right join. Please, 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 if you forget anything, don't forget this one, because this is a common, very, very common interview question. And whilst it gives you, in this particular instance, the same number of rows, it doesn't give the impression of there being ghosts. So the first one, we had the feeling that there were ghosts in the system. Look here. And see, so there's nobody here. There's nobody at this address. So maybe there is a ghost living there, right? So this is where we have ghosts in database. But when we run this one, take note of that same line 106. And we check again, we don't see evidence of ghosts. Right? And that is what we want to see. Any questions so far? Any questions so far? So we go to the fourth type of join, which is the full join. So all we do here is just change left to full. Is that all right? That's all we do, and see what we get. And then let's see if we can give an explanation to what we have. Okay, so we run a full join and that gives us 137 records. Now, what is the difference? Why is that the case? A full join is usually very, very good to in comparing data sets. It's good when you want to compare data sets. You want to see what you have in this data set and that data set. So you want to compare two or more tables to see exactly what you have in all. So with a full join, just as the name implies, it takes everything in both tables. It takes up everything in both tables and shows them up, right? So that is the full join. We can do the same on the Adventure Works table and it would give us the same thing. And that I think would even produce a lot more records than 317, which we got the last time. But let's see how that works. If we execute this Let's see what we got. Oh, this also gives, so it looks like that's the number of, so this also gives us 317. So it looks like we have 317 records in that table. Yeah, that's cool. No worries. So that gives us everything. It throws everything we have in both tables to us. Okay. Any questions so far? Any questions so far? Okay, let's go on to the next kind of join. Cross join. And to do this, I would need to, we don't have, so a cross join simply produces a Cartesian product of tables. It produces a Cartesian. When I say Cartesian, do we understand that?
Do you like coordinates, X and Y axis?
Oh, beautiful. 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 Do you have a maths background?
No, I don't know.
I see. Right. That's nice. So if you know the X and Y axis, that's the Cartesian plane, the X and Y axis. When you're drawing your graphs, when we were in secondary school, when we used to draw graphs, right? You have the X axis, you have the Y horizontal axis, the vertical axis, X and Y. You plot things on the X and Y axis, and as you move further, you are even told there is a Z axis. So you have that gives you the three-dimensional planes. So that's what is called the Cartesian plane. Let me just have these two, let me just use these two columns as an example. This column and that column. Assuming that I do a cross join on these two, what is going to happen is that for every instance of one here, every instance of one matches every instance of every attribute that we have in this column. So what is going to happen is that one will match 18, 7, 14. So we have 118, 17, 114, 13, 13, 126, 7, 112, 112, like that. It would match everything we have in this. And then when one has finished, what is going to happen is that 2 now takes over, and 2 matches everything that we have. And then when 2 has finished, 3 takes over and matches everything. So the problem with a cross join is that you need to be careful. Assuming you have a database or a table that has got 1,000 records, if you run a cross join on any two columns of that table, what is going to happen? It has 1,000 records. The table has 1,000 records. Right? So what do you think is going to happen? How many records would you end up producing? Any mathematicians in the house? Okay, so if it has 1,000 records, then you end up producing 1,000 times 1,000. Remember I told you that if, for example, we do a cross join on these two columns, then 1 is going to take 18.7 all the way down. So 1 is going to repeat itself on 317 rows. 2 is going to repeat itself on 370 rows, like that. So if there are 1,000 records, each attribute in the record would repeat itself 1,000 times. Okay? So one needs to be very, very careful when we're doing a cross join. And you don't normally see cross joins actually done in the real world. Cross joins are mainly used by mathematicians to do Cartesian to generate Cartesian products. So whilst it is not something you would use often, it is good to know. Okay, it is good to know. Now I'm going to do this, but I'm going to change the source of data for that. And let me see where I have the cross. I have a table for cross joins. Where is this? Where is this? Where is this? Where is this? Hold on, let me. Well, where is the cross join? Where do I have the cross join? Let me see. Okay, so these are the cross joins. Okay, they're under this, so they're under SQL training. So let me change the source. Under SQL training. Okay, so what do we do? Let's first of all say we have this. Select everything we have under cross join. They've been named cross join 1, cross join 2. You can name it whatever you want. It doesn't really matter. It's just for the purpose of teaching. That's why the cross join has been used here. Okay. So select from the first one is called cross join 1. Select from cross join 1, and let's see what we have there. So these are numbers 1, 2, 3. Okay. Let's see what we have under cross join 2. Okay, let me execute both. Okay, let me just select them. Okay, so cross join 1 is this, and cross join 2 is that. So cross join 1 is numerical 1, 2, 3, and cross join 2 is ABC. So you see how restrictive this has been, just to make it easy. So we have just 3 three records in each table, right? 3 records in each table. So how many records do you think we would eventually end up having if we cross-join these two tables? How many records do you think we would have? Oh, come on. I just gave you, I used 1,000 to, okay, when we have 1,000, we said it will happen 1,000 times. So that will give you 1 million, right? If you have 100 records and you cross-join, each record would join onto other records 100 times. So you have 100 times 100. So if in the same way, if you have 3 in each table, it's just 3 times 3. So eventually you would end up having how many records? 9 records, right? So select all from cross-join 1. So like I said, the word that the tables have just been called cross-join. But assuming, just close your mind to the word cross-join here and just call it anything you want in your head, okay? The key word we want to use here is cross-join. That is why I'm saying that, so as not to create confusion. Cross-join, that's the cross-join word. We want to cross-join 1 to cross-join 2. We're joining cross-join 1 to cross-join 2. And what happens? So you see what has happened here. One has joined to A, has joined to B, and has joined to C. 2 has joined to A, has joined to B, and has joined to C. 3 has joined to A, B, and C. Right? So, like I said, we would have 9 records altogether. We have 9. Is that clear? Any questions so far? Any questions so far? So imagine we wanted to do, if we want to do a cross join, for example, on this adventure works table. Involving 317 records. Well, that will be quite a hell of a lot of, that's 370 times 317. Okay. Right, so let's make progress. The last kind of join that we want to look at is called the self join. Somebody spoke about outer join. Now, there are various variants of the outer join, but they all boil down to either the left or the right. So outer left, outer right. self-join. I'll use a table from, okay, I'll use the table from here. So I'll still be in my SQL training table. Right. Now, before we do we talk about self-join, I just want you to know one thing about self-join. There is no SQL statement called self-join. There is no SQL statement called self-join. The name self-join comes about as a result of how the join is operated. But in theory, you do not write a self-join. Like we write a cross join, a left join, a right join. No, you don't do that. There is nothing like self-join. Okay? Now, like I said, the name comes about as a result of how the operation is carried out. So a self-join basically means joining a table onto itself. Right. So let's, for example, say we are looking at this. Select all from let's call that, we want to use that table, right? Manager hierarchy. We want to use this. If we execute this, this is what we have. Now, what this tells us simply is that it's giving us all the managers in the business. You know, you have a business, you would have departmental heads and that kind of thing. You have, even within a department, you would have heads of, you have managers who have managers, right? So that is what this is actually about. So this is what we have from this table, this particular table. These are the managers in this particular business, so to speak. They have a person ID, which is their employee ID, a full name, and a manager's person ID. Apart from their personal ID, they have a manager's ID, the manager's person ID, right? Okay. So this is the person ID, for example. And this is, let's take this person, for example. Who do you think her manager is? Can somebody tell us who her manager is?
Caroline Goodwill.
That's it. Yvonne Smith's manager is Caroline Goodwill. How about Jeremy Wright?
Andy Goswell.
Andy Goswell. How about Stephen Knott?
Nobody, I think it's like the overall manager.
Oh, beautiful. This person is very brilliant. So Stephen Knott is like the CEO. He's the overall manager. He hasn't got a manager. That is why that place is null, right? He hasn't got a manager. Right. So what can we do? Can we have a manager's manager? So mind you, all these people in the business are managers, right? They are all managers. So let's take this one step at a time. Let's assume we now have this. Let's take this one step at a time, because this can be very, very, very tricky. Let's assume we take employee, we take the employee's person ID. Select employee.person ID. Employee.person ID. And then we have employee's full name. Employee.full name. As employee name. And we also have the manager's full name. So we want, I'm trying to do here is find the manager's manager. So for example, when I ask, who is this person's manager? Who is Yvonne Smith's manager? You were able to tell me that is Caroline Goodwill. But how do we show that this is the case in a query? So that is what we are trying to achieve at this moment. So every manager here has got a manager except this person. So we want to be able to show in a table, in a simplified view, not asking people, assuming we have 1,000 rows of this, it will be very, very difficult to know managers of all managers, right? So we want to simplify the whole thing such that we can see at a glance which manager manages the managers. Right. So that is the query that I'm trying to write at this point. So what I'm saying is that select employee person ID. We're selecting the person ID. And then having selected the person ID, what we are saying is that we should also select the employee's full name and give it an alias, an employee name, right? Or name it as this. Then we also select the manager's name. So these, we are just creating we are creating columns. At this stage, we haven't really done anything. We are just creating columns for this, okay? So we have manager's full name. As manager's name, as manager name. Manager. Manager name. Employee.person ID. Employee, okay, this is wrong here. There is an error here. Employee.full name as employee name. Manager.full name as manager name. And then we say that we should, from the manager hierarchy, what we do, like I said, there is nothing like you don't do a self join. What you do is you do either a left inner, you can do left inner, whichever one pleases you, but it is best, always best, when you are not sure, to do a left join. Left join, manager hierarchy, left join manager hierarchy. Manager hierarchy, which we call man, on employee, emp dot manager, underscore manager's person ID, this should be equal. We want the manager's manager. So we want to join from the manager hierarchy table. We want to join the manager hierarchy table to the manager's. This is where it's a self join. You see that the tables are the same table. We are joining manager hierarchy onto manager hierarchy. Manager hierarchy onto manager hierarchy, which is why it's called a self join. If you look at the other joins, the tables were all different. The leading tables were all different. So here, we have dim employee onto dim employee sales territory. We have employee and address, right? So in those cases, the tables were different, but here the table is the same. We join in manager hierarchy onto manager hierarchy. That is where the name self-join comes from. Employee, there is an error somewhere. Where could it be? Okay, I think, let me see. Okay, alignment. Could it be alignment? I think so. It's not alignment. employee.person ID, employee full name as employee name, manager's full name as manager name, from manager hierarchy, left join manager hierarchy, man, on, employee, okay. Employee, I think this is a dot, right? Employee dots, manager person ID is equal to man dots person ID. Okay, what is the issue? What is the issue? What is the issue? Okay, let me see. Let me run it and see what the issue might be. Manager.person ID could not be bound. Why is that? Manager.full name could not be bound. Why is that? Why is that?
I think the problem is from the column names.
Yeah, it's from the column name.
This employee dots person ID is just person ID. Employee dot full name is just full name.
Okay, let me change that and see if it would work.
What was the reason you put that EMP dots person ID?
To employees to separate, like I said, every manager here has got a manager. So we
Okay.
are trying to separate the subordinate managers to call them employees. You get?
Yes.
I'm not sure why it's not working, but let's see. It should work. It's still the same thing. And
Is
this
that
is,
man before person ID and alias?
pardon?
The man dot person ID on the last line is this an alias?
You mean this one?
After the equal to sign.
No, it's the man dot person ID is from here.
Okay.
Okay, I think I see where the problem is. Okay, I've seen the problem. We've given this an alias. Let's give this an alias.
Sure.
I think I've seen the problem. M dots. M dots. There's one more. M dots. Yep, that's it. That was a gray one. So simply ignoring this one here is what caused the problem, right? Just this that we didn't put. If we execute this now, do you see what you spoke about? Okay, let me execute both. Then you would see what we spoke about earlier on. The manager's manager. So when I ask the question, Yvonne Smith, who is a manager, somebody said Caroline Goodwill. And you can see here, Yvonne Smith's manager is Caroline Goodwill. The same thing, Alan Cox's manager is Caroline Goodwill. And Caroline Goodwill's manager is, who is Caroline Good 224? Who is 224? Pardon? Caroline Goodwill's manager is Andy Goswell, right?
So,
Yeah, so Caroline Goodwill's manager, let's see, where is Caroline? You see Caroline Goodwill's manager is, oh, Stephen Knott. So Caroline Goodwill's manager is Stephen Knott, right?
yeah.
And the same thing, Andy Goodwill's manager is Stephen Knott. Andy Goodwill's Goosewell. Andy Goosewell, where is he? Where is Andy Goosewell? Andy Goosewell. His manager is that. So you see how it makes this very, you know who is, you are getting to know who is the boss of the bosses. Right? You're getting to know who is the boss of the bosses. Now, this can even be taken a step further. So like I said, this can be really, really, really hairy. It can be very hairy. If you're not careful, slide thing, and then you are thrown off. Just like we were thrown off a while ago. We can take this one step further. Again, left join. Again, manager hierarchy. Now, what I'm trying to do here is actually to show that Stephen Knott is the overall boss. So let's call this, let's call him the top man or the CEO. The CEO obviously is the top man of the business, right? So let's join manager hierarchy. Which we will call as top man on the manager's manager known by that person's ID, and this should be equal to the top man's person's ID. Top man dot person ID. Okay. So what happens here? If we run this query, what is going to happen? Let's see what happens with this. Just this one. Let's see. We already know what has happened with that. So let's just look at this one alone. The difference between this and the last one is that this clearly shows that Stephen Knott has no manager. So Stephen Knotts is the top man of the business. If we just leave it here, okay, let me add that one to it and let's see if there's a difference. Is there a difference? Is there a difference? Let's see. 1, 2, none. Let's see here. One, two, none is the same thing, right? Yes. Um, so basically this and that are the same. I was expecting this to be slightly different, but it's like it's the same thing. So let me just take it out. Okay, any questions? Any questions so far? If there are no questions, I have a question. Let me see who I can call. Damola. Oyi Damola. Can you hear me, Oyi?
Yes, I can.
Okay. What will you do if you were given a right join to execute?
I will change it to left join.
You will change it to left join. Why will you change it to left join?
Uh,
Okay, how will you change it to left join?
by switching it around.
Switching what around? Who can help her? Somebody to help her, please. I want certain words, certain
By
particular
switching
words.
the tables around.
By switching the lead table
Switching the lead
around.
tables. Switching the
Yeah.
lead tables. So when you switch the lead tables, what do you do next? What do you do next when you switch the lead tables? Just switching the lead tables doesn't solve the problem.
Then you change right
Then
join
you
to
change
left
right
join.
to left. That's what I'm looking for. Then you change right to left. Let me see if I can get another question for somebody. What is the difference between inner join and left join? What is the difference in results between inner join and left join? Who can I call? Let me see somebody to call. Let me look for somebody to call. Somebody to call. Who can I call? Who did I just call? I called Ayo now. So let me see who can I call. I'm not going to call Ibi. I'm not going to call Adroja. I'm going to call Babajide. Yes, Sebabs.
Yeah. The inner join kind of takes into, okay, the left join, let me start with that. I will start from the known to the one I will struggle with. Okay, the left join brings together all the rows in the table. It gives you a wider overview of what the table, of all the table, of the two tables that you are trying to bring together, you're trying to join together.
Mm-hmm.
While the inner joins is used to compare. Is it compare now? Oh, yeah, I would say compare to. Or it has a slightly limited number because it's looking at maybe there are repetitions in the rows. I hope I made some sense.
You are trying to make some sense, but you haven't made it yet. Okay, let me
But
see if somebody can help you. Let's call somebody else to help you. Do you want to call a friend? Call a friend. Call a friend in the group here. You know that game, 50-50, call a friend. Call a friend.
Who is my
But
friend?
don't call EB. Let's call a friend for
Ayobami.
Ayobami. Okay. Ayo, your friend has called you, so help your friend.
I agree with what he said.
You do?
Yeah.
Oh my, you are helping to crucify your friend, actually. Eh? You are helping to crucify, assuming your friend is at the point where they say if he hasn't got any help, it's going to be dealt with. And then you come and then you say you agree with him. Then they will join you to your friend though. Don't agree with him just like that. Because like I said, he's trying to make it make sense, but it's not really, he hasn't hit the points.
Near the point.
Yeah. Right. So can anybody help us? Anybody at all? First of all, I said the inner joint is best for performance. Is best for performance. You want to see exactly how the system produces its results. Okay, so it's best for performance. So it would give you it tries as much as possible to, okay, let me explain it from this other angle. It would give you a view which involves producing records that are in the left table so long as they have matching records in the right table. So the key word there is matching, the key words matching records. There has to be matching records in the right table. Okay, so if you take all the records in the left table, they have to have matching records in the right table, which is why it's good for performance. Right. On the other hand, the left join would give you everything in the left table, whether or not it has matching records in the right table. So that gives you the totality of everything in the left, whether it has matching records in the right or not. Okay. All right, so let's see if we can get another question. Joins is actually a very, very important thing because as data analysts, if you happen to be working on SQL, you might be joining different tables to produce records, which you would eventually work on, turn into visualizations. So it's very, very good you get this concept of joins. It's very important. What other join can we have? We know what a full join is. Full join is full join, like the name says, churns out everything. But what
About
is,
full outer join.
pardon?
Full outer join.
Yeah, it's full. Full is full.
Okay.
Full is full, whether outer or full is full. That is why I didn't put the outer. Cross join. What's a cross join used for? What's a cross join used for? Anyone? So a cross join simply is used in producing a Cartesian product of the records in the in tables, in two tables. It's used in producing a Cartesian product. Cartesian product. That's the main thing. So if you execute that, we have a Cartesian product of records. Cartesian. One matches everything in one first table would match every other thing in the other table. So that if you have 1 million records in the two tables, you would end up having how many? Wow, 1 million records in one table. That would be 1 million times 1 million.
By 1 million.
So it can be sometimes dangerous to do a cross join if you do not know the number of records in the tables. But usually if you have to do a cross join, it's not going to be a lot because it can be crazy. The output can be really, really crazy. So it's usually the tables are quite restricted to a few records. And most times you would actually not do cross join. You would hardly do cross join in a workplace. Hardly. In fact, if you do cross join maybe 1% or maybe 0.5% of the time, I don't think you would get to do cross join. But like I said from the beginning, it's something that is good to know. And even if you are at an interview and they ask you about joins and you start naming cross join, it's highly likely that people at that interview may even not know what a cross join is because it's not a concept that is known by a lot of people. Right? So if you start naming cross join and then you add self join onto it and you explain what a self join is. Now, what is a self join and why is it called a self join? Yes, who can tell us that? Let me see if I can call a friend. The person I call here will be my friend. Let me see if I can call a friend. Friend. Aduroja. That's my friend. I like that name. Where is Aduroja? Where is he? Has he run away? I saw Aduroja a while ago. Where is he? I saw him. I can't see Aduroja. Is he here? Pardon?
I think it's dropped.
He's dropped off. Okay.
I think it dropped off.
Okay. Okay.
Yes, okay, watch out for the phone.
Okay. So who can help us with self-join? Paradise, can you help us with that?
Um, Self-join is when you need to combine some components of the same table together. That's like adding a table to itself. Just selecting perhaps columns that you need to be able to form the view or the table you want.
Okay, so you were beating about the bush a bit. Simply put, don't even try to over-explain what it is. Self-join, as the name implies, means joining a table onto itself, period. Joining a table onto itself. That is what a self-join is, right? Don't trying to over-explain it might land you into a territory you would not be able to explain. So simply put, a self-join is joining a table, the same table onto itself. And that is how the name has been derived. It is not like there is a command, an SQL command called self. You can add that to it, assuming you are answering an interview. There is no SQL command that is called self. So but the name self-join is as a result of the way the query is executed, and that means joining a table onto itself. Any other questions? If there's no other question, we would end here for today. I think, yeah, any other questions? No other questions. So we would end here. Next week, we would do strings, string handling, another very important topic in SQL, how to handle strings. Then after that, we would do how to handle, maybe we will do how to handle dates. I'm not sure yet what we will do, but we'll find. But next week, we will do string handling. Yeah. Okay, so I wish you all a very good night and a happy weekend. Thank you very much for coming.
Thank you so much.
You're
Have a
welcome.
nice weekend.
And you too. Bye.
Bye.
Thank you.
Paradise, I'll send the notes to you, yeah?
All right.